Hello, welcome to chapter 21 in Trump. My name is Evan Sasamadu from Royal Level today. So before we get started with some practice problems, let's go ahead and learn more about the IGV. IGV simply stands for the Integrated Genome Viewer. This program will allow you to view DNA and protein sequences, but it does not allow you to edit the sequences that you have. In this video, I'll be showing you all you need to know about the IGV to be able to solve some problems. This is the chicken lysosome gene. This is a perfect example to show how IGV works. First things first, let's look at chromosome 1. Chromosome 1 is right here. Just follow the arrow. This bar indicates where we can see the gene that we are looking for. So chromosome 1 in all have about 100 genes. But we're going to be looking at only one lysosome today, which is shown in the red bar right here. We all know a gene is a small part of a chromosome. So to see the details of the gene, the lysosome gene, we will first need to zoom in to find the gene view. So this whole entire section is the gene view. Then we can even zoom in more finer to find the sequence view. So this entire section down here, if you follow the arrow, just like it's this whole entire section is the sequence view, and this top part is the gene view. Now let's go ahead to see what we have in the gene view. This part is very important to know because it's the basics for every problem that you solve. So first, we have the promoter region right there. This is the promoter. There's an arrow pointing the right. Then we have the 5' UTR, which is the gray right there. It's UTR stands for the 5' untranslated region. Then when you come down here, this small part will show you start codon. Then we have our exon 1. Exon 1 is right there. This is exon 1. This whole part, this whole blue part is exon 1. Then we have intron 1. Intron 1. We have exon 2, intron 2, exon 3, intron 3, then that should be our exon 4. Then right after exon 4, we have our stop codon right there in between the 3' UTR and exon 4. So we have right here, this is a 3' untranslated region. The stop codon is right there. So let's take a look at the sequence view. What do we have for the sequence view? So this down here, as I said before, is the sequence view. From just looking at the sequence view, you can just tell the RNA polymerase goes from left to right because you can see 5' to 3' right there, and the 3' to 5' based on where you're looking at. So from this, we can just tell that the bottom strand is the transcribed strand, and the top strand is the coding strand. So this top strand is the coding strand, then the bottom is the transcribed strand. The good thing about the IGV is that it shows you all the possible translations of the mRNA depending on which reading frame is used. So we know that these green boxes with the M is your start codon. This is very important to know. M is methionine, which is your start, depending on which reading frame you are using. The red boxes shows you the stop codon, also depending on the reading frame which is being used. These letters here gives you the single letter code for the amino acid. Now, how do you tell which frame you're using? Look above to see the protein sequence and find the corresponding frame below. So valine, leucine, alanine, it's in the protein sequence. So to find the corresponding frame, you just have to look down, go all the way, continue down. You see CTG codon in the DNA. It's CTG, which becomes CUG in mRNA. If you look up in the codon table, you see that CUG is Lu, as you expect. The reading frame stays the same in each exon, but it may change when going across an intron. So we have leucine, which is in the protein sequence. When you come down here to the DNA, you see CTG, but in the mRNA it becomes CUG. Right. Now that we know all about the IGV, let's go ahead to solve some of the challenge problems that we have. So the first challenge problem is asking us to give the index number of any one of the nucleotides in the start codon for this gene. So how do we solve this problem? The first thing I would do is to highlight the exon sequence right here to see where this problem is going to start, the gene is going to start. So we have methionine, which we know is the start codon, which is corresponding to ATG. ATG is in the DNA form. The mRNA is going to be AUG. When you compare AUG to the code table, you could tell it's the start. So we know it corresponds to these nucleotides of index of 29, 30, and 31. So any one of these indexes can be correct for our first problem. So let's go with 29. The second problem is asking us to give the index number of any one of the nucleotides in the stop codon of this gene. How do we get to the end of the gene? Okay, so you see this right here? You just go to the end of these gene between the blue and the gray. Click it right here. And we know there's nothing that's going on in this area, so we know for a fact that this is our last stop. It's corresponding to TGA. TGA is in the DNA form, and mRNA is going to be UGA, which we know that is the stop codon. So let's see what we have with the index. 3580, 3582 right here, 3583, 3584. So any one of these nucleotides can be correct for the second problem. So let's go with 3582. And the great part about this program is you can verify your answer to see if it's correct or not. So let's check answers. And yes, we got them correct. Okay, have a great time. Thanks for watching and enjoy your rest of your semester. Well, all I am